Hi guys, how are you? I think you are all fine. Myself, I'm Krishna, chemistry faculty, mentor and guide with vast experience children. Today we are going to do with this, what do you call as your degree of unsaturation, double bond equivalent, index of deficiency hydrogen. So this is the one of the best concept to find out different type of isomers like structural and stereoisomers. Okay, children, incline to my lecture, all of you. Just incline to me and concentrate on my lecture here. Let's go through this, children. So what's this degree of unsaturation? What's the use that already I have given in the introduction? I'm starting with the definition of this degree of unsaturation. It's nothing but, children, it's nothing but the difference in between number of hydrogens with respect to the acyclic saturated hydrocarbon and the given molecular formula. So that's results in the formation of pi bonds or cyclic structures. That's called what you call as your degree of unsaturation and double bond equivalent. Very simply, children, it's the difference in between what you call as your number of what do you call as hydrogens with respect to a cyclic saturated hydrocarbon and given molecular formula. So that's called degree of unsaturation. That's called double bond equivalent. That's called index of deficiency of hydrogen, Baba here. Let's move to this. The formula related to this, the degree of unsaturation is equals to 2C plus 2 minus hydrogen minus halogen X, that's halogen, plus nitrogen, or delta NH by 2. What's the delta NH by 2, sir? That's the question arises for you children. Just I'll show you children. C4H10 is there, and also you are given C4H6. See, it's given formula. It's the saturated acyclic hydrocarbon, what do you call as carbon formula, right? The difference of hydrogen 10 minus 6 is equals to 4. 4 by 2 you can write. So this is such kind of formula applicable to this hydrocarbons, right children? You got my point here. We should compare that the given formula of hydrogens with respect to the saturated hydrocarbon having the number of hydrogens. See here, let us start with one example, children. It's C4H10. That's nothing but alkane. That's nothing but what you call as here C4H10. Remove the two hydrogens, then you are getting one pi bond. That is going to be the alkane. And remove this terminal two hydrogens, you are getting two pi bonds. That resembles what you call as here alkyne. And here we are doing in one step, 2 moles of hydrogens has been removed, or 2 molecules of hydrogen has been removed from the single molecule of butane and butane. Now what's you are getting, Baba? Here it's you are getting what you call as here 2 pi bonds, and also what do you call as here 2 moles removed means 2 pi bonds, and remove 1 mole of hydrogen or 1 molecule of hydrogen results what do you call as here, this is also going to give us this compound here, right? This which we have done here. When we have eliminated 1 mole of hydrogen, then we are going to get this what's nothing but what do you call as this formula is going to have 3 pi bonds. It's clear, children? Suppose the same formula we are doing in a different way. We are removing the hydrogens. 1 molecule or 1 mole of hydrogen is eliminated from this formula. Then you are getting 1 cycle. When you are removed another molecule of hydrogen from the opposite ends, then you are going to get here the cycles are going to be seems to be 2, but this is 1 cycle, Baba, this is second cycle, and this is going to be third cycle. That's what's called here. This is what's 1, and what do you call as here 1 cycle, and this is what's called here 1 cycle, second cycle, and third cycle. It's clear. Next, move to this, and next example also we are going to do what's called here. See, I told you in the beginning itself, we can find out the isomers. What kind of isomers, sir? structural and what do you call as here stereoisomers. So let us see this. First of all, we have taken acyclic saturated hydrocarbon, that is N-butane. Its degree of unsaturation is 0. When you remove one molecule of hydrogen, degree of unsaturation is 1. It gives 1 pi bond. Degree of unsaturation is 2, 2 pi bonds. Degree of unsaturation is going to be, what's we are given is 3 here. This is one molecule is eliminated. Hydrogen is eliminated. So overall, C4H10 to C4H8 and C4H8 to C4H6 and C4H4 we are getting here. Right, Baba, here? Then what do you call as here? Let us see. Suppose degree of unsaturation is 0, it's acyclic. If degree of unsaturation is 1, it's 1 pi bond and 1 ring. All of you listen, children, don't hesitate and don't divert your concentration. Here, this is 1 ring plus 1 pi bond is also possible. See that, suppose, let's write this. Let's write the rings also. One ring I have written cyclobutane. The another ring that I have written cyclopropane substituted with methyl group. See here, these two are going to be considered as chain isomers, Baba, here. Why? Because the parental ring is going to be different. That's why these two are considered as chain isomers. Right? It's clear. Right? Let's move to this also. Degree of unsaturation is 2. 2 pi bonds are possible. 1 pi 1 ring is possible. Let's go to this also. And whenever it's 2 pi bonds, one example is given here, and 1 pi 1 ring is given. This is what do you call as the compound which we have shown. And this is also cyclobutane with 1 pi bond. And it is acyclic with 1 triple bond. And this is also acyclic with 1 triple bond. These two are going to be positional isomers. Why? Because this position of pi bond, triple bond is going to be differs here. But 1 ion is this and but 2 ion is this. That's why these two are considered as what do you call as here positional isomers. And one more ring I am writing here. This is also possible. Like this, children, we can write different kind of isomers with the help of degree of unsaturation. It depends on the nature of question here. Suppose you are asked positional isomers, right? You can write this also. These are going to be considered as positional isomers. Ring chain, I mean, suppose chain isomers. These two are going to be considered also as considered as chain isomers, right? Because the parental ring is going to be different, right? Clear, children? And comes to this degree of unsaturation is 3, 3 pi bonds, 3 rings, and 2 pi bonds plus 1 ring. I'm writing here 3 pi bonds. It's what we have done is going to be beyond what's known as here 1 3 enine. That's what you call as beyond 1 3 enine. It's one structure. This is one more ring structure I am going to write with respect to this. It is also possible with respect to this, and also with respect to this. These are the possible rings. Some of the examples I have shown, and some more also possible guys here. So please concentrate here, children. Then next we are going to do this also. For example, the same formula with this, what we have done is going to be, we have taken C4H8, right? When you have taken C4H8, take this. We are taking cyclobutane. Whereas these two hydrogens are going to be on wedge, I mean projected towards us, right? So that's when they are projected towards us, that's considered as cis. Clear? And that's opposite carbons. Related to that, these two opposite carbons connected with this bridge bond, right? And then we will go for this also. Let us see this also. Whatever is called here, it's we have seen. This is going to be cis and trans isomerism is going to be seen. And this also we are doing. It's clear, no, children? It's C4H8. I'm sorry, children. This is going to be, it's C4H6. 6, which we are going to do. So this is cis and trans is also possible. It's clear, Baba. And next one is what we are doing with respect to this. Whatever the degree of unsaturation, and it's already given formula with respect to degree of unsaturation. Certain rules are there, Baba, here. 1, 2, 3 rules are there. If halogens are there, we are subtracting -1. If nitrogens are there, we are adding +1. If oxygen sulfurs are there, no additions, no what do you call as subtractions to be done with respect to this formula. These are all the 3 rules. Instead of writing such a lengthy way, we can do this. For example, I'm doing with this also. Nitrobenzene is given. See, I have given the structure for the sake of an idea here, children. That's C6H5NO2 is the formula also I have shown here. It's clear. C6H5NO2 means 12 plus 2 minus 5 plus 1. Why? Because 1 nitrogen is there. Its degree of unsaturation is going to be 5. See, Baba, here, 1 ring, 3 pi bonds, and 1 double bond in nitro group. See here, 1 ring, 3 pi bonds, and 1 double bond in nitro group, right? So that, Baba, here, when we have seen this example also, it's nothing but the degree of unsaturation of nitrobenzene. It's clear, children. Then when we are going for example number 3, you are only questioned aromatic positional isomers. What is the aromatic positional isomers? With the given formula, let's do this. You are getting 4. 4, it's unsaturation. 3 pi bonds, 1 ring. I have given already in the question as aromatic positional isomers. With respect to this, the aniline is possible. The positional isomers are going to be orthobromoaniline, metabromoaniline, and parabromoaniline. Not only that, also, children, we will get N-bromoaniline also. So, this is what in with respect to our NEET and JEE is concerned. This much is enough, Baba, here. So that, and what we are given is sometimes they'll question, because when you have gone through various topics of our organics, they will ask what is the degree of unsaturation of DDT. So DDT means it's an insecticide, dichloro-diphenyl trichloroethane. So that straight away they'll give the formula. If they have given formula, they may or may not go for what you call as DDT or not. Okay, now, right, children? Okay, you're getting me. That's we have gone through this. 28 plus 2, it's done with carbon, and 9 is subtracted hydrogens, and -5 is related with chlorine. You are getting its degree of unsaturation as 8. It's a good question. It reflected many times in our NEET and JEE, right? It's what we have seen. It's dichloro-diphenyl trichloroethane. 3 plus 3 pi bonds, 6 pi bonds, 2 rings. 8 is the degree of unsaturation. So degree of unsaturation related to the pi bonds, and of course ring structures also. This also we have done with respect to this, and clear, Baba, here. And what we are going to do this with respect to this. Example number 5, C4H6 is given. You can do. Compare with alkane. What is C4H10? 10 minus 6 is equals to 4 by 2. Its degree of unsaturation is 2. You are given fullerene like C6. How do we have to do, sir? It's very simple logic. We can do with this formula also, but I'll do that later. First of all, here you have given 60. It stands for number of carbon atoms. N plus 1. You will get it directly. It's a very simple, tricky one. And C72 is given. 72 plus 1, 73. Its degree of unsaturation is 73 with respect to the rings, right? Cn is given. Degree of unsaturation is N plus 1. See, Baba, here we can apply the same formula also, which we have already discussed in the previous case. Du is equals to 2C plus 2 minus hydrogen minus X plus N. You will get the same answers, 61 and also 73. Okay, children, let's move to this also another concept also that's going to be discussed with the cubane, octanitrocubane, prismane I'm doing. Here is a very simple logic, children. Let's take this very, very simple trick we can apply here. Its cubane is going to have what do you call as this 6 planes are there. Number of planes minus 1. You will get its degree of unsaturation as 5 with respect to the cubane. Got it, children? Why? Because cube is going to have 6 planes? No, that's clear. But you are coming to this example is octanitrocubane. It's a very explosive compound, Baba, here. It's when you have gone through this octanitrocubane, we can move to our own formula. That's nothing but the old formula which we have done. See, it's you are given C8, 18, 18, 8, 8 plus 16 plus 2, 18, and nitrogens or 8 are added. This is going to be 13. But here, whenever this is substituted with other compounds, we have to proceed with our own formula. Got it, my children? See, listen here. We have done with this cubane, number of planes minus 1. But when you have given this octanitrocubane substituted with certain compounds, it's a very good explosive. Followed. So this is octanitrocubane. Then we will go according to our formula. Then we will get its degree of unsaturation as 13. It's a good question also, children. Prismine can do it, no? Prism has 5 planes, na? So 5 minus 1 is equals to 4, children. So this is what we are doing with respect to this. And one more last but not least here, C6H6Cl6, we can do, apply the formula, and we are getting as 1 as degree of unsaturation. It's C6H6O2Cl2, degree of unsaturation as 4. And this is the conceptual base of the degree of unsaturation widely applicable to find out the isomers of various types, right? Okay, children, in the exercise part, we will do certain questions also. So this concept is useful for all categories, NEET, JEE, and foundation students also in the new pattern of education, right? Thank you, children. Thank you very much. All the best. Go through all the content which we have discussed here, children. Thank you. Thank you very much. Yeah. Next also we will discuss children with certain concepts. Okay, then I'll stop it here.